Hello, my name is Martin Brummel, and I'm here to tell you about a project we've been doing in association with my colleagues, Dr. Jean Hawley and Dr. Nigel Andrew at the University of New England, looking at how dung beetles may change greenhouse gas emissions associated with cattle dung. I'll start by acknowledging that we and our university acknowledge that we live and work on primarily the country of the Ainawan people, who are the traditional custodians on whose land this university stands. We also would like to pay our respects to elders, past, present, and emerging. Our experimental setup was a closed chamber experiment, incubating beetles in a temperature-controlled greenhouse for about 3 months. We had these cylinders with sand and cattle dung placed in them, and then we added beetles to half of those chambers. And then over 2 days apart or 4 days apart or later as the experiment progressed, we measured the greenhouse gas emissions from those chambers. So we were looking at carbon dioxide, methane, nitrous oxide, carbon monoxide, and ammonia. Carbon dioxide results show a clear pattern of an initial strong emission of carbon dioxide from the no beetle control chambers, and this early spike of CO2, this early pulse of CO2 was greatly reduced if there were beetles present in the chamber. However, there was a second pulse a few days or weeks later, and that pulse was larger and broader, so more spread out in time, lasted longer, if there were beetles in there working on the dung. Methane is a similar story. We have in the control chambers a lot of methane in the first few days, much less in the beetle chambers, but the beetle chambers produce considerable amounts of methane at about 2 to 3 weeks later from the start of the experiment. Nitrous oxide, as is very common in my experience when looking at nitrous oxide from soil systems, extremely variable. We're not really sure that there's a clear signal here. It does look like there is, again, in the control chambers, an initial pulse of nitrous oxide that is absent from the beetle chambers, but otherwise the data are very confused. Carbon monoxide was not a major story in our experiment. The emissions were not strong from any chamber, but we do again see a suggestion that the beetle chambers suppressed that initial pulse of carbon monoxide from the fraction of our chambers that produced any carbon monoxide at all. And in fact, all of them stopped being active in this sense by about day 35 or day 40. Ammonia also finished its activity by about the end of the 3rd week. But in those first 3 weeks, what we saw was ammonia emissions associated almost entirely with chambers containing beetles, and that the control chambers emitted extremely low amounts of ammonia. So in summary, what we see with the carbon dioxide and the methane is a reduced initial peak, but a pulse of emissions in about the 2nd to 3rd week. Nitrous oxide and carbon monoxide are highly variable. We're not really sure that there is a clear pattern there. But the ammonia is interesting because it comes almost entirely from the chambers that contain beetles, and we're trying to follow up on that. This delayed emissions pattern to us suggests an opportunity to reduce total emissions through further management activities, especially with beetles that are out in paddocks, digesting and burying dung in Australia. Thank you.